Hey everybody, this is Mr. Munson, and we are looking at section 8.5, a pretty quick section, not necessarily time, but just in quantity. We're going to kind of culminate all of our properties for different shapes, look at some indications on some figures to help us decide from the properties which shape it is. So let's go ahead and get started. So first off, we're looking at 8.5, identifying quadrilaterals by their properties. So let's just kind of rehash over on the right-hand side, basic kind of flow chart, if you will, of our properties. So we start off with quadrilaterals. So all these circles that I have, they're all part of being quadrilaterals. So to the left, thread in the red. We have trapezoids, and then out of trapezoids comes special trapezoids. That's where the legs are congruent. Now, each one of those items carry a certain set of properties. To have a trapezoid, you have to have only one set of parallel sides, and there's a whole list there, and we've given those in the past. In isosceles, we add to it that the legs are congruent, and once we take a trapezoid and make the legs congruent, then that forces the diagonals to be congruent. It forces the pair of base angles to be congruent, and so on. Now we've listed all these properties for all these threads, the red being a trapezoid, the blue being parallelogram, and then the green being kite. We've listed these in the past, and so I'm going to encourage you to get that list out. They might be in different places and culminate it together, listing kite, put down the word kite and then list all the properties and so on, okay, as well as all the other figures. That will help you manage what we're getting ready to do in the next series of moments. So this is a Venn diagram, and basically the green represents the quadrilaterals. Every shape that would be a four-sided figure falls inside this shape. So suppose this star represented some shape I found. It obviously is not a four-sided figure. It just represents a place point. So right here, that if I had a shape that sat where that thing was at, I'd know that it's a quadrilateral four-sided figure, and then it would have all the properties of every four-sided figure, and that is the sum of the interior angles equals 360. It's definitely got four sides. Okay. Now, if I took that shape and made sure that it had only one set of parallel sides, then it would form it into a trapezoid. And then if I put it so that the legs were congruent on that trapezoid, then it would fall inside this circle. Notice how anything in this circle does not exist inside the rhombus and parallelogram, because it can't be both. So this would represent a four-sided figure that's a parallelogram. So both opposite sides are parallel. So now we have two sets. And then we add to it that all four sides are congruent. We add that all four angles are congruent or right angles. And then if both of those exist, then we have square. And then we have a kite. And a kite represents a four-sided figure with no parallel sides, which there's a lot of quadrilaterals that don't have parallel sides. But what makes this kind of interesting is that it has two sets of adjacent sides that are congruent. So that might be just a fill of words for you. So what you want to do is go back and look at a kite and make sure you understand statements like that. So one of the things that you're going to be asked to do in this chapter is to look at diagonals and things like this, where you're just looking at the shape. It's not necessarily drawn for you. And you're looking at the properties, in this case diagonals, and trying to determine what kind of shape it is. So now with two diagonals, we know that it's a quadrilateral. So we start off already knowing it's a quadrilateral. Every one of these are. So we'll just know that. Now what we're going to do is decide, do we jump into the thread for trapezoids? Do we jump into the thread for parallelograms, or jump into the thread for kites? Now what I want you to notice is that all of our lists over here come from the parallelogram threads. We don't have to worry about trapezoids on these, okay? So if you take a look at the diagonals on this very first one where I'm at, what we have, when we see that information, we need to be able to interpret and understand what that says in words. That basically says the diagonals bisect each other. Okay. Now, there's nothing about the diagonals being perpendicular. There's no evidence that they would be congruent. And so we are stuck with just that one tidbit. So what you want to do is put me on pause and see if you can figure out which shape, what's the name of this kind of shape where the diagonals bisect each other. You can look at your chart. You can look at the listed properties or whatever. Go ahead and put me on pause and see if you can figure this one out on your own. So what I find out is that the very first shape coming out of the quadrilaterals in the parallelogram thread is a parallelogram, and so the parallelogram has diagonals that bisect each other. Now that's true for rectangle and rhombus, and also for square, but there's no other indications that would tell me it's one of those higher order names. Okay, let's go on to the next one. Here's one. Let's go on to number 2 right here and see if you can put me on pause and come up with the idea what that one is. Write down all the information in words to help you process what we're dealing with here. Now for me, what I just see is I see that the diagonals bisect each other. The markings there are helping me understand that. Also, the right angle there is telling me the diagonals are perpendicular. With that very first one, I can conclude that it's a parallelogram, right? All right, so now we're in the thread of parallelograms, just not any old quadrilateral, but it's a parallelogram with diagonals that are perpendicular. And that means it's a rhombus. All right, now I don't see any other indication that tell me it's a rectangle. As a matter of fact, for it to be a rectangle, the diagonals have to be congruent. Now the pieces here are congruent. That's a parallelogram. But when you look at this set, they're not marked the same way. So if this was a 5, this would be a 5 because they're congruent, right? But the other ones are not 5s. It would have to be something else. I'm making these numbers up now. But if that was a 10, that was a 10. In other words, this whole diagonal would be 20, and this one would be 10. So that's kind of an indication that these are not congruent. If it was, then I would say it was a rectangle. All right, so we stop with that it's a rhombus, and we move on to the next one. Let's take a look at number 3 here. See if you can do that one on your own. Okay, so when I look at this one, I see the diagonals bisect each other, and the diagonals are congruent. That's what these all being the same tell me. Hopefully you can see if that was, let's say, 5, then that one would be 5, that one would be 5, and that one would be 5. And to find the length of this diagonal, just add the 2 pieces and I get 10. And this one I would add these 2 and I get 10. And that's an indication that the diagonals are congruent. Okay, so with diagonals being bisectors of each other, that's a parallelogram idea. Okay, so now let's step into the next one. Okay, the diagonals are congruent. That's a rectangle idea. Okay, now there's no indication that it's a rhombus, so we're just going to stop there and call it a rectangle. All right, go ahead and go on to number 4. See if you can do that one. So as I'm going through these, I'm simply kind of walking through, all right, what do I see that allow me to see it's parallelogram? What do I see that allow me to see that it's a rectangle, and so on? Well, with the diagonals being bisected, that's a parallelogram. Now that it's a parallelogram, let's check to see if you see any evidence that it's a rectangle or rhombus, okay? Diagonals being congruent, tell me it's a rectangle. The diagonals are perpendicular, tell me it's a rhombus. And I'm hoping your experience at this point tells you, since it's both of those, it's got to be a square. All right, I hope that you got those right. Now let's take a look at these figures and see if we can interpret what they are. Now this one here, I just want you to recognize and hold on to it. Notice that it has one set of parallel sides that are congruent to each other. First thought is that that's a trapezoid, okay? But I'm going to show you it's actually a parallelogram, and you're just going to remember the shape. So let's just start with that shape, and I'm going to add to it a diagonal. Now since the lines are parallel, I know that angle and that angle are congruent. I also know by the reflexive property that that middle side is congruent to itself, right? The diagonal reflexive property. By this, I can conclude that this triangle here and this triangle here are congruent by side angle side, okay? All right, since they're congruent, their corresponding parts are congruent, okay? That means that as there is this angle here that's congruent to that angle, there has to be an angle here that's congruent to another angle on the other side, and it's going to be that set. So this angle is congruent to that one by corresponding parts. All right, so take a look at this carefully. I have a line, 2 sets of lines here. cut by transversal, and the green angles show that they're congruent. Those are alternate interior angles that are congruent, and that means my two lines, my two green lines, are actually parallel to each other. And if you take a look now, I have two pairs of parallel sides, not just one. So you just need to commit to memory when you see a four-sided figure with the one pair of parallel sides that are also congruent, it automatically means parallelogram. Okay? Now there's nothing else in there to tell me that it's a rectangle or rhombus, so we'll leave it at that. Go on to the next one and see if you can put me on pause and come up with, what is this figure? All right, let's take a look at this next one and see what you can come up with that one. Use your properties again. This is obviously dealing with angles, so see what you can figure out on that one. All right, so this is what I know. I know the missing angle has to be 76. That's just by the fact that the sum of all the angles in a four-sided figure has to equal 360. So I subtracted all the known angles away and I get 76. But that once I look at it, I realize that all the consecutive pairs of angles are supplementary. So if you take a look at this angle plus this angle equals 180, this angle plus this angle 180, and so on. Okay, so that's a feature of a parallelogram. Now there's nothing there. Certainly it wouldn't tell me that it's a rectangle. Otherwise I would see right angles here. I know it's not a rectangle. There's nothing about the sides to give me an indication it's a rhombus. So I'll just stay with its parallelogram. All right, have a go at trying to figure this one out, thinking through stuff about angles. I always look to see if there's congruent angles or supplementary angles and things like that. All right, so what I recognize is that it has one pair of parallel sides. I know that because these are the only pair that are supplementary to each other. That makes these sides parallel. If you take a look at these set, they're not supplementary, so that tells me the other side are not parallel. That leads me to believe it's trapezoid. So now I'm going to look to see if there's any features that would tell me it's an isosceles trapezoid. If it was an isosceles trapezoid, then I would know this is a base here, so I would know that the base angles are supposed to be congruent in an isosceles trapezoid, and they're not. So I have to leave it as a trapezoid. All right, here's the last one of this type. So see if you can put me on pause, look at the information given, and see what you can conclude. All right, this one's kind of tricky, and it's much more thought-provoking than the ones before. We definitely know all those become right. I want you to know that these are total of 90 degrees, and the reason I know that is these little pieces have to be 45. I get those by using the triangle sum theorem, right? So I have the 90, and then I have the 40 already given over here, so that leaves me 45 there. This one has to be 45, and that's how I get those 90s there. All right, just keep that thought now. Because this is a isosceles triangle, those two angles are the same. I know that those two sides are the same. And so with that, I know that this side is congruent to that one because they're both on the same 45. Of course, since this one's the same in this triangle, whatever, whoops. Let's get that back up here. This is congruent, so opposite angles and all that stuff. All right, so that means that that side is congruent. So now we're looking at this triangle. It's an isosceles right triangle. That leaves me these to be 45. All right, so now all those angles are 90, and that makes it a parallelogram because all the opposite angles are congruent, or all consecutive angles are congruent, either way. So it's definitely a parallelogram. Now all the angles are right, so that's a rectangle. Now definitely each one of those little 45, 90 triangles are congruent to each other. We could use side angle side to clarify that, but that makes it a rhombus. Since all these triangles are congruent, their corresponding pieces are congruent. So it's a rhombus, and so I will conclude, since it's a rectangle and rhombus, that's a square. All right, let me scroll through your homework problems, and then we'll be done. All right, bring that completed next class. Make sure you show your work and show Carol all your answers.